So in this video here, we're going to have a look at using the rule for the nth term in a sequence modeling geometric growth or decay. So just a quick recap of our last video. Just the rule that we used was V0 is your principal, and so Vn plus 1 is equal to R, a capital R, multiplied by Vn. That's where your capital R is equal to 1 plus your rate divided by 100. So your rule for individual terms of a geometric growth and decay sequence. So if you were trying to find a specific value, so after 6 payments of your compound interest loan, what your value would be, you would use something like this. So we've still got VO as our starting value, our initial value. And then we will go down here. So this is our original form, that same one we've got up the top here, but then at the next line we can see to find the specific payment that we're looking for, we've got Vn is equal to R to the power of n multiplied by V0, so your initial value. So we'll move from this step here to this one here. This is a shortcut because if you remember in the previous video, we had to just continually plug this into our calculator until we got to the one we were looking for. So if we're looking for, say, if we're looking for a 30-year loan and we're compounding interest monthly, that's going to take way too long to plug into your calculator. So we can just find out how many months or how many payments we've made and pop that in as our n value here. So one thing to remember, if we move across, is depending on whether we're looking at compound interest loans and investments, so that's increasing, or if we're looking at reducing balance or depreciation, we have to change the symbol here in our capital R value. So if the amount is being borrowed or invested is increasing, so it's compounding, we need to have a plus in there. So it's 1 plus R over 100, like it was in our previous examples in our previous video. But if it's a reducing balance, we have to put a negative value down because we're losing that amount off our item that's depreciating. So we'll go through these first two questions here. So a principal value of $10,000 is invested in an account earning compound interest. So the interest is being compounded at a rate of 9% per annum. And so the rule for the value of the investment after n years is shown just down there. So it's Vn is equal to 1.09 to the power of n multiplied by 1000. So it's just down here. So first one here, looking at question A. Find the value of the investment after 4 years. So we need to correct to the nearest cent. So we're looking at dollars here. So if we need to substitute the values in here, so we've got V, so we're looking at 4 years. So V4 is equal to 1.09 to the power of 4 times 1000. Sorry, 10,000. 10,000 because that is our initial amount. So that is our VO value there. So V0. So if we calculate that, V4 will be equal to 14,115 dollars. So we need to Calculate that to the nearest cent. The value here gives us 0.816, so 0.816, but we need to round that to 2 decimal places because the cents only go to 2 decimal places. So let's change that to 8.2. So our value after 4 years is $14,115.82. So to have a look at question B, we need to find the amount of interest earned after 4 years. So across the whole 4 years, we need to find the total amount of interest earned. For this one here, what we need to do, we need to subtract our initial value from our final value there. So from our V4 value. So if we do 14,115.82 minus 10,000, so our initial value, 10,000, is equal to, let's just put an I here, I for interest, is equal to I. So we should be able to do that pretty easily. We don't need a calculator to do this one, so it's $4,115.82 is our interest over the 4 years.